Okay, we are in a Bayesian game, and in this case we have two players. Okay, first of all, to say that here we have player 1 and player 2. Okay, player 1 and player 2. Now we have those players can make two different kind of choices. The first one is to travel to Australia, and the second one to travel to Denmark. Okay, A for Australia and D for Denmark. Now player 2 is in doubt. He doesn't know whether to go alone or to travel with player 1. So in this case, in the first type, player 2 wants to travel with player 1. Okay, and here player 2 wants to travel alone. Okay, now the thing here is, and why we are in a Bayesian game, is that player 1 doesn't know whether player 2 is in type 1, this is going to be type 1 or type 2. So he doesn't know. So let's say that here we have player 1, okay? And he doesn't know whether player 2 is in this type or in this one. So he thinks that with probability 1/2, player 2 is going to be in this type, in the first type, and with probability 1/2 is going to be in the second type. Okay, so now we are going to compute first of all the table of best responses for player 1. Okay, so let's do that. Okay, here we are going to have this table. So the thing here is that player 1 has two different kind of strategies, A or D. I mean Australia or Denmark. But player 2 has 4 different kind of strategies. Okay? And I'm going to explain it now. The thing here is that player 1 is going to choose always A or D, and the payoffs are the same: 2, 2, 0, 0, 0, 0, 1, 1. Okay, the first number is the payoff for player 1, and the second number is the payoff for player 2. But we can see that the payoffs for player 2 change. For example, here we have 1 and here 0. And why? Because they are different kind of types. Because here player 2 wants to travel with P1, and here P2 player 2 wants to travel alone. So the payoffs change. Okay, so player 1 has two kind of strategies: Australia or Denmark. Okay, but player 2 can do Australia here and Australia here. So A can do Australia here and Denmark here. So A, D, D, A, and Denmark. Okay, now how can we compute the numbers in this table? Okay, for player 1, yeah, with probability 1/2 in here, if we are here, yeah, we are A, and here A and A. Okay, player 1 always A, and player 2 AA. So here A and here A. So we are in this gap and in this one. So here we are computing the best responses for player 1. So the first number. So with probability 1/2, he's going to be here. So 2 times 1/2 plus with probability 1/2, he's going to be here. So 2 times 1/2, and this is equal to 2. So here we are going to have 2. Now here Australia for player 1, but player 2 now plays Australia-Denmark. So here Australia, so we have 2. Now we have 2 times 1/2 plus here in Denmark 0 times 1/2. Yeah, and this is equal to 1. So 1. And this is how we can compute the best response of player 1. Okay, so here also we have 0 and 2, so 1 and 0, 0, 0. Here we are going to have 0, yeah, 0 and 0. Now Australia, Denmark, so 1/2. Denmark, Australia 1/2, and Denmark 1. Okay, and now which are the payoffs for player 2? Okay, the best response for player 2 is going to be always the second number. Okay, so these ones, yeah. So as I said, player 1 has only one type, yeah, and player 2 has 2 different types. Okay, so now let's say that to compute the Bayesian Nash equilibrium, let's say that player 1 plays Australia. Okay, plays Australia. What is going to be the best response for player 2? Okay, the best response for player 2 is going to be, hey, we are here, no? Australia. We said that player 1 chooses Australia. Here also, Australia. So we have here 1 or 0. So what is going to choose player 2? He's going to choose 1 because 1 is greater than 0. So 2, he's going to choose Australia in the first type. Okay, the best response for that is going to be Australia in the first type. And in the second type, 2 is greater than 0, so Denmark is going to be the best response in the second type. So we have the player 2 will play AD. Yep, AD. Now, if player 2 plays AD, yeah, we are here now, plays AD, what is going to do player 1? 1 is greater than 1/2, so he will play Australia. So then player 1, best response of 1 is Australia. And we can see that plays A and the best response is A, so this is a Bayesian Nash equilibrium. Okay, now we are going to do with another possibility, that is that player 1 plays Denmark. Okay, in this case the best response for player 2 is what? Denmark. We are here now and here. So in the first type we'll choose 2 because it's greater than 0, so Denmark, and here 1 is greater than 0, so Australia. So we have Denmark, Australia. Okay, we go here, Denmark, Australia, and the best response for player 1 is going to be A, because Australia, because 1 is greater than 1/2. So best response here was DA, and the best response of 1 was A. Now A does not coincide with Denmark. I mean, it's not the same Australia and Denmark. In the first one we saw that Australia, so Bayesian Nash equilibrium. In this case, no, because it is a mutual best response. Okay, to be a Bayesian Nash equilibrium, it must be a mutual best response. In this case, it is a mutual best response. In this case, we have not a mutual best response because we can see that here plays D and the best response is A. So not a Bayesian Nash equilibrium. Okay? So, in the end, the Bayesian Nash equilibrium is going to be Bayesian Nash equilibrium always in terms of strategies. So is going to be what? A D. Here A for player 1A, player 2 AD. So that will be the strategy of Bayesian Nash equilibrium, and this is going to be the final answer. Okay, this is the final answer. This is the strategy that is Bayesian Nash equilibrium. So that's it. Thanks.